Okay, so let's get an idea of how to use transformations. We kind of talked about them in the last video, and we set up these 4 rules. So if you have a negative in front of the function, you reflect over the x-axis first. If you're adding something inside the function that moves the opposite way that many spaces on the x-axis. If you're adding something outside the function, then it moves that many spaces on the y-axis. And if you have a negative inside the function in front of the in front of the x. Then it reflects over the y-axis, and it does that last. Okay, so let's just do a few examples real quick. So say we have a function f of x equals square root of x. How does g of x equaling negative square root of x minus 3 minus 7 transform? Meaning, how would it shift on a graph, or what would the transformations be? So we have our given function, square root of x, and then we have stuff happening to that given function. So we have a negative outside of it. That would be the first thing that's happening. We have a minus 3 inside of it. See how it's inside? Because it's inside square root. So it has a whole square root, and the minus 3 is inside of it with my x. That means it's inside the function. It's got the minus 7 outside of it. So the first thing is a negative. So that's in front of the function, because it's not inside of it. It's not inside square root. It's in front of it. So it's going to reflect over x, and it's going to do that first, so it's going to turn it upside down. Okay, next we got the minus 3 that's inside the function, so that's going to move it along the x-axis, and it's going to go in the opposite way. So minus 3 would make you think it's going to go toward the left 3, but we're trying to make up for that minus 3, so it's actually going to go to positive 3, so it's going to go to the right 3. Minus 7 is outside the function, so that moves on the y-axis, and that goes the way that it seems. Minus 7 is going to go down 7. And that's it. That's all it's really asking is how this thing moves, how the graph would move. Okay, so get another one. Wrote it out a little different. Say I have f of x equals absolute value of x. What are the transformations involved in g of x equaling absolute value of negative x plus 7 plus 2? So again, going in order, I have a minus. My minus this time, though, is in front of my x. It's actually inside my function because it's inside the absolute value bars. So that is going to reflect over the y, and it's going to do that last. So I'm going to write that last. The plus 7 is inside the function because it's inside the absolute value bars. And so it's going to go on the x-axis, and it's going to go the opposite way. So it's going to go toward the negative 7. So left 7. The plus 2 is outside the function because it's outside the absolute value bars. That's going to go up 2. So that's it. Okay, let's look at another one. This time we weren't even given a function. We're just given f of x exists, basically. Where are the transformations for g of x equals negative f of negative x minus 3? So again, I'm going to go in order. And I don't know the function, so even if I wanted to graph it, I couldn't. I'm just going to show how it would shift if I could graph it. So I got a negative in front of the f. That one is obviously in front of the function, obviously in front of the f, since, well, this time it's just an f of x. So that's going to reflect over x, and it's going to do that first. Okay, I got a negative inside the function, in front of the x. That's what I mean by negative inside the function. It's got to be a negative in front of the x, or the x term. Okay, so that's going to reflect over the y-axis, and it's going to do that last. And then I got a minus 3. My minus 3 is inside the function, so it's going to go the opposite way, so it's going to go toward a positive 3, so right 3. And I'm being lazy and using arrows. You can write right 3 or up 2 for the previous one, or however you want to. That's it, though. Okay, so really it's just memorizing these 4 transformations and using them to show how things move. So now we're not going to be asked to do this in this class, but this is something for those going on to pre-cal and 155 you will see. So just look at the next 2. And we'll find a main and range just because we will do that in this class. Say we're given f of x equals absolute value of x, and that's graphed. So this graph right here, this v, that is the graph of f of x equals absolute value of x. So using this graph, I want to try to graph g of x equals absolute value of x minus 1 plus, absolute value of x minus 7 plus 1. So let's see how it would transform. First up, I got the minus 7. That's inside the function, so it's going to move right 7. Then I got the plus 1. That's outside the function, so it's going to move up 1. So I'm going to take a point on this graph. I'm moving every point on the graph, but I'm going to take a point on the graph that would be easy for me to redraw from. So this bottom point here would be very easy for me to redraw this V from that bottom point. So I'm going to take that bottom point, I'm going to move it left, 1, 2, 3, 4, 5, 6, 7. Move it right, I meant 7. So I moved it right 7, and now I'm going to move it up 1. So I took that bottom point, I moved it right 7 and up 1. Now I'm going to go ahead and redraw the graph from that. It's just a sketch. So that's it. I now have this graph of an absolute value, and this is my graph of this g of x function. So real quick, find domain and range of this. And I'm looking for the domain and range of the g of x function, so of that graph I just drew, not the original one. So if I look at the domain of this, does it look like it's going to go all the way to the left and all the way to the right? And it does. So it's going to be negative infinity to infinity. If I look at my range, does it look like it's going to go all the way down and all the way up? And this time, no, it's not going to go all the way down. It's going to go down to 1. It's going to start at 1. And it's going to hit 1. There's a point there, so I'm going to use a bracket. And it's going to go up to infinity. Okay, so let's try the next one. Given that f of x equals square root of x, that's graph below. Graph g of x equals negative square root of x minus 2 minus 3. I guess I should have put in some tally marks in here. We'll only put in 5 since we're not going over 5 anywhere. Okay, so we're given the graph of square root of x. That's the graph that's already drawn. Now I want to graph my g of x from this. So I want to again do the transformation. So I have a minus. My minus is in front of the function, so that's going to reflect over the x. And it's going to do that first. So I am going to do that first. So if I take this graph right here, and I reflect it over the x-axis, that basically means I'm doing a mirror image, or I'm flipping it over the x-axis, or I'm rotating it 180, however you want to think about it. But I should end up with a graph that looks like this. It should just be an upside down graph of the original. Okay, so now I'm going to take that graph, and let's see, I have a minus 2 here. That's going to move it right 2. And I have a minus 3. So that's going to move it down 3. So I'm going to take that graph, and I'm going to move it right 1, 2, and move it down 1, 2, 3. So I'm going to move it right 2 and down 3, and I'm going to redraw the graph. So this should be my graph of g of x. Okay, so again, let's find domain and range. So if I look at the domain, does it look like it's going to hit all my negatives and all my positives? And this time, no. It has a stopping point. It stops at 2. So it's going to go from 2 to the positives. I'm going to use a bracket for 2 because it is a point. It does hit it. Okay, for my range, does it look like it's going to hit all my negatives and all my positives? So all the way down, all the way up. And this time it does look like it's going all the way down. So that'd be negative infinity. But it's not going all the way up. It's only going up to minus 3. So that's the highest it ever gets. So negative infinity to minus 3. And again, I'll use a bracket with minus 3. Okay, so hopefully that kind of makes sense how to read these, how it shifts. And once you learn some of these graphs, how to actually move them. Next video, we'll graph some exponentials and logarithmics with shifting.